congatec with business development in Northern Europe. And today I'm about to tell you a few words about congatec as a company, how we have been driving the innovation leadership during the past years, and then something about hardware building blocks and software building blocks, what we have available for our customers. So as you can see, we have this 20-year logo on every slides, and that's because of last December we had the 20-year anniversary of congatec. So the company was founded 20 years ago, and now we are harvesting what we did what we did during the past 20 years. And what we are today, we are a global company with more than 400 employees worldwide. Over the 20 years, we have shipped more than 10 million solutions to our customers. And on the map, you see all these orange dots. These are where we have our own office, and the green ones, they represent our production partners. And how we have been driving this innovation during the past 20 years is by being a active member on these standardization organizations, PIC-MG for ComExpress and ComHPC, ESCET for SMARC and Q7. We also have a very close cooperation with these silicon vendors, AMD, NXP, Intel and Texas. And also from the software side, we have a in-house real-time capable hypervisor to enable you to consolidate hardware or for various real-time use cases. Some of you might have seen in the news during summertime that we did some company acquisitions. So we acquired a large share from the Kontron subsidiary called JumpTech. And this is quite interesting because we have more headcount now in the company. So we are now 500 plus persons, and we have more resources to design more interesting products for you. And if we look back to the rear view mirror, what we have been doing during these past 20 years is that we have been expanding the global coverage, taking the company into new markets. We have had our hands on with new module standard publications, and also within the past 10 years we have also been acquiring companies to increase the different solutions, our portfolios. And then if we talk about these computer on modules, open standards, so earlier today Titus also had few words about what are computer on modules and what kind of benefits you can have, that you can get scalability, future-proof, and easy scalability for your application. And this is what we have as of today, and some of them are recommended for new designs, while the others are more of a sustain existing designs what you might have. And speaking of the JumpTech acquisition, this is the first time I can show slides with the different color scheme than the traditional orange from congatec. And what we have here are some interesting devices which will fill the gaps in the congatec product portfolio. And maybe the most interesting one to begin with is the ComHPC server module with the Intel Ice Lake D low core count CPU. And what makes this interesting is the size, that typically the ComHPC size D module is 160 by 160 millimeters, while this small form factor is only 120 by 160. So it's a very nice candidate for all sorts of rugged applications because of the on-module memory. And this is already in mass production, the small one, and also the larger size D is also in mass production, and the larger one is also available with the high core count CPU, allowing you to have 10 to 22 cores within your application. Another interesting device is the basic size ComExpress module with the 13th generation Raptor Lake P CPU. And typically what we have seen that different module vendors are doing with these Intel single chip SoC designs, that because the chip is so small, then let's make it a compact design. But in this case, the basic size enables you to have more PCI Express lanes with the optional PCI Express switch on the module itself. And next to this, we have the same CPU on compact size, both from congatec portfolio and also from Jumptech. Then we have perhaps the most powerful CommExpress Mini module, what we got, also based on the 13th generation Raptor Lake P CPU. And what this offers is a leap in performance in terms of CPU power, but also a leap forward with the on-module storage, as this one features the NVMe SSD versus the traditional eMMC storage, what you see on most CommExpress Mini modules. Also, we have a high-performance Atom CPU family on a CommExpress Mini, and this will bring the 8-core CPU on this platform. And also we have a variant with the Armstrong Lake CPU on CommExpress Compact and SMARC, and all these are in mass production and samples are available. Then the latest and greatest from congatec side is our TC750. One is visible over there if you want to have look how it looks like in reality. So this CPU platform, known as Arrow Lake by Intel, is very scalable in terms of power it can consume. So you have CPU options ranging from 15 to 45 watts. It has a very powerful graphics that you can use this for all sorts of AI applications because of the high AI performance, up to 99 TOPS. And with this module, you can have the most amount of memory on the compact size, 128 gigs. Then we have a CommHPC module, and what makes this one interesting, that maybe you have heard about the Intel hybrid architecture, that they have the P cores for performance and E cores for efficiency, but it's not good for deterministic applications. And this is the first time in many years that Intel is launching a CPU with the homogeneous microarchitecture. So they have a couple of variants of the CPU with the P core only. So that's a true powerhouse for your applications where you need deterministic behavior. This will be available before end of the year, and mainly depending on the Intel release schedule for the CPUs. Then we have another candidate, this time from AMD, with a homogeneous architecture that all the CPU cores are the same. This one has a dedicated NPU, a very strong graphics, and is going into mass production end of this year. Samples are available right now. And AMD is getting quite strong in this embedded market. So this is the first CPU after some pause, and next year there will be another interesting platform from AMD also having industrial temperature options. So I have been talking about few different module families, SMARC, CommExpress, CommHPC, different CPU family names like this, like that. But how do they compare to each other? So I think the challenge always is that what CPU or which module platform is the right one for my application. So I have this quick summary here of what is available on each module standard and what kind of features you can extract from a certain CPU family. So we have ARM CPUs available on the SMARC platform next to x86, while all these CommExpress, CommHPC, they are x86 either from Intel or from AMD. And Intel, of course, they have their own marketing names, Intel Core, Intel Atom, or Core Ultra. Some of them are available with industrial temperature options, -40 to +85, while others are commercial temp from 0 to 60 degrees. From availability perspective, the ARM CPUs, they typically have a lot longer life cycle or availability period than the Intel ones. But I guess typically we can say that 10 years is the average for these Intel CPUs with the industrial use cases. Those ones targeted for a PC client or general embedded market can have a slightly shorter availability. All the x86 platforms, they are ready for virtualization technology. They can run our hypervisor, and on the x86 modules, we have the hypervisor evaluation license directly available on the BIOS itself. From the AI use cases, the ARM CPUs, they have NPU on chip. Also, some of these x86 platforms, they have an integrated NPU, while others are relying on instruction set dedicated for AI use cases. And then if we compare which is which and what can be achieved with them, so with the ARM platform, you can have the low power and they are very cost effective. You can also have the 8-core industrial Atom CPU on it, the Raptor Lake, the best scalability on an industrial feature set, Meteor Lake, NPU, GPU, and homogeneous core design for AMD and strong graphics. And then if we look at the performance landscape, that you can always read the feature set from a data sheet, that how many USBs, what kind of Ethernet, PCI Express lanes and such. But then what is the performance CPU versus another CPU family? And here we can see that the Raptor Lake, which is currently a couple of years old, not being the latest and greatest, is still very scalable and well performing amongst the other platforms we see here. And then if we look at the graphics part, that what kind of GPU performance we can get out of these CPUs. So as expected, AMD is very strong here, but Intel also has some matching options with their recent releases. And as the AI has been the hot topic today, and thanks for Jaakko for having the presentation earlier in the morning to describe all these different legislative things behind this to lay the foundation. So I have something more practical and more hands-on. So basically the AI can be split, or how to utilize the AI can be split in two different categories. So training, to train the model with the data set you have to do what you want. And then the inference, that's the ability of the AI model to infer or extrapolate conclusions from the data you are feeding to the AI model. So you have the model, then you have the data set you train, and then you optimize the model on your specific hardware, and then you use the model as intended. And then where are you doing it, and what kind of platforms you use for these? Then the training is a very performance oriented task. So when you feed a lot of data to train the model, then you need plenty of performance to shuffle the data and train your model. So that is typically done on large-scale servers or data centers. But then the actual inference at the edge can be done with the low-power edge devices. And I have a couple of examples here that what kind of platforms we have, and the AI performance in TOPS, and TOPS is trillions of operations per second, that how much data they can process. And here we also have some typical use cases for AI and what kind of performance they require in order to run properly. So audio detection, image recognition, autonomous robots, medical imaging, and this is what we have today. And in future generations, of course, the performance will be increased. So until now, it was just the hardware platforms, individual building blocks. So now we have something more application ready as a condensed solution what we can offer. So hardware and software combined. So everything builds on top of the hardware, the module, ComExpress, ComHPC, SMARC on the bottom. Then you can have the optional virtualization layer on top of the hardware, and then we can offer a pre-installed operating system. And at the moment, we offer Ubuntu Pro from Canonical, and then real-time Linux and the Control X from Bosch. And on top of these, we offer pre-validated software building blocks. So from congatec, we have the A-Ready IoT stack, and then the Bosch Control X. With that, you can have their own device management portal and app store to bring in applications to your own installation. And one interesting thing regarding the Ubuntu Pro is that they offer a period of 10 years of updates for your system. And they also have a certified hardware lab. And basically what you can have if you pick a congatec module, that you can take your own system with our module and your carrier into the Canonical lab, and whenever they release an update patch, then they will test it against your hardware, and they will test as long as the patch is installed without any glitches, and then they will release the patch that you can deploy it into production. So with the certified hardware lab concept, then you can be sure that any updates you get from Ubuntu will work and not cause any hiccups in your systems. And then we have the A-Ready IoT, and basically this is our solution to help our customers to meet the EU Cyber Resilience Act requirements with over-the-air updates and monitoring and additional features. So our story is the same what we just heard from Digi, but with different wording and different pictures. So if we use a vending machine as an example, so in the past the vending machine was a standalone installation sitting somewhere remotely, and the technician did a drive-by every now and then with a pre-defined schedule, and then after the technician left, then the vending machine was there on its own, and you had no idea how is it doing. Is it fully functional? Is it having enough inventory, or is it empty, or did someone vandalize it? So you had no idea to know how is it doing until the technician went there the next time. So what we have to offer is the A-Ready IoT software stack, and there are 3 different options. The COM manager to manage the computer on module itself. Then the application manager can be extended around the peripherals and applications around the COM manager. And then the most comprehensive setup is the fleet manager, where you can configure your system that you can manage it as a fleet instead of one single instance. And this table here illustrates how these different categories compare to each others, and all of these can be used in conjunction with the Cloud Connector. And how the COM manager works, so basically you can remotely manage the COM, so you can start it, reboot it, shut it down. You can deploy updates remotely for BIOS, for VMware, or the IoT stack, or for the hypervisor. And you also have a dashboard of the health monitor of what kind of hardware you are running and how is it doing. Then the next step is the application manager, which offers the exact same features as the COM manager, but here you have some additional features like notification engine. So whenever there is some activity you have triggered to trigger an email to be sent out, then you get an email. And also you can have a OPC UA client or server MQTT broker, and this is also a very, let's say, a multi-protocol capable data pump that you can use this to get data out of your system and set up a database and so on. And then the fleet manager, that you can manage your fleet of devices or installations with a single click. You can deploy updates to every device for the module itself, for the application, and also for the other software you are running in your system. And then the cloud connector, then if you are using this, then you can just configure the system to upload the data to the cloud of your choice. And at the moment we are supporting the Amazon cloud, Microsoft Azure, and the Deutsche Telekom cloud. So as a summary, so in the past the device was there on its own, slow response to failures, and just you happen to get the update of the system status when you went physically on the spot to see how the system is doing. But today, as the devices are connected, you are able to see real time that the health status and business figures, and if you have a vending machine, then you can also trace the cold chain, for example, if you have any foods or drinks in it. And then if the system is flagging that I have a problem, then you can have a fast response time to maintain your device. And then let's have a couple of words about our virtualization technology. So we have a in-house hypervisor, and as mentioned, this comes as an option on every module that you can turn it on or off on the BIOS. And it's easier for you to test how virtualization can be run in your system, that you can consolidate hardware, you can run multiple operating systems. So if you were juggling that, should I run Windows or should I run Linux on my system, with this hypervisor you can run both Windows and Linux in your system. And it's not restricted only on congatec products, so the hypervisor runs on any x86 platforms. So if you have a different platform where you would like to consolidate hardware, then this would be suitable for your use case. And we are also soon introducing a secure version of the hypervisor, which is the IEC 62443 certified, that it matches with the industrial automation cybersecurity certificates. And our hypervisor has a healthy appetite for various operating systems, so it supports a few different real-time operating systems like the RTOS 32, the Tenacious from InTime, and the real-time Linux, and also different general purpose operating systems like any Windows or any Linux. And you can also run virtualization on top of virtualization. So one option is to run the Microsoft Hyper-V on a container on top of the hypervisor, but you can also set Windows running in your system and multiple Hyper-V instances within the Windows. And we are currently working on to have the Bosch Control X also to support the hypervisor, that you can run Control X as one instance next to other operating systems in your design. And one customer reference what we have is a company called Onosokki. So they had a system consisting of 7 computers in total, and they optimized their system design in a way that it got replaced with only one computer running the hypervisor, that they consolidated all the functionality into one hardware. And this reference story is available from our website to download. There are also other interesting documents, white papers, case studies on our website. So that's it for my presentations, and I guess Veija will have some couple of questions at this point.
So any questions, Timo? Nope. I have, of course.
Of course.
Can you go back to slide 21? It's a long way, sorry. This one.
This one.
If you want to run AI inference on a module and on battery power, where do you draw the line? Which model would work?
I would say that that depends on the size of your battery and how much time you have to wait to get the conclusion.
Okay, so yeah.
Because with the performance, the case is always that if you have high performance, then you can do it on a short cycle. But of course, doing something with inefficient hardware, it takes time, or that it's always the trade-off between power consumption or performance. So this is also the same. And depending on the performance you have, then it's also that how complex model you can train to run in the system.
Also, the A-Ready IoT platform is quite new.
Yes, so we released this one in the springtime this year.
Are there any deployments in the field? Anything in Finland?
I can't comment on that. But we do have existing customers for this platform.
Yeah, okay.
So basically, what this A-Ready IoT is a piece of software which runs as a service on your computer. So with Linux, it runs as a service in the background and is consuming maybe 2-3% of the CPU cycles. And then with the Windows applications, then at the moment the implementation is to run it in Docker. But we are working on to have that one also to be run as a service.
Yeah, and the last one, you have modules based on ARM and x86. When will you introduce the new was it Dragon Wing or what's the CPU from Qualcomm? When will you announce your first products based on that?
The Dragon Wing is the Qualcomm stuff.
Yeah.
I don't know. I'm not allowed to comment on that one.
Okay. All right, thanks. Thanks.
Okay.